Concept 8, it's very like the previous problem, but with inequalities. So you're looking at like more than or less than. Anytime you're doing inequalities, think money, money in your pocket. If I have more than $10, $12 is more than $10. Fantastic. $8 is not more than $10. Okay. Is $10 more than $10? It's not more. So you're looking for like more than or equal to, or something like that. If I have less than $2.37 in my pocket, $2 is less than that. $3 is not less than that. So you got to figure out, similar to how you would set up concept 7, concept 8 is kind of the same thing, but you got to understand, do I need to be less than this because I need to be less than this total, or do I need to be more than this total because maybe I need to be less than because this is all the money I have, so whatever I buy needs to be less than this amount. Or I need to be more than this. I need to collect more than $10 because $10 is how much, you know, something's going to cost, so I need to collect more than that in order to pay for it. That's concept 8. Concept 9, still dealing with inequalities and solving inequalities, or simplifying inequalities. So 2x plus 3y is less than 12, but we know x equals 3. So really all we do is we plug it in and we solve it like any other equation. When we get down here, we have to ask ourselves, y is less than 3, which is fantastic, but if you think about a number line, less than 3 goes all the way to negative infinity, because negative 10,000 is less than positive 3. So can we have negative answers? If we can, then we would just leave it like this here in red. No problem. If not, we basically have to say, look, we have to stop at 0. And maybe if 0 is an answer, that's okay. We would make this or equal to. If 0 is not an okay answer, we would leave it as it is and say, look, we have to be bigger than 0. We have to be less than 3, but we have to be bigger than 0. And this is the and concept that we'll kind of get into. But this is less than, this is greater than, less than or equal to, greater than or equal to. Basically, as long as your alligator is eating the bigger number, is how I learned it, then you're in good shape. It's just read this particular way. So as long as, I mean, I could have had these switched and say 3 is greater than y, which is the exact same thing. The alligator's still eating the bigger number, so it's still fine. So can you have negative answers? If not, throw that 0 in front. Maybe the or equal to if 0 is or okay. But just be careful that you just don't go, oh, y is less than 3, duh, I'm done, because maybe negatives aren't such a good thing. Solving equations here. Going back to some of the like term stuff that we did in the earlier concept, 3x and 2x become 5x, not 5x squared. We're not multiplying anything here. So I'm at 5x plus 5 equals 15. Subtract, divide, finish solving. Not too terribly hard for concept number 10. Concept 11, same thing, but now we have inequalities again. They love to have these inequalities. So again, we combine like terms. We'll just start with this first one. 7y minus 4y is greater than 9. Combine like terms, divide, y is greater than 3. Well, on a number line, greater than or less than is represented by an open circle, because 3 is not greater than 3. It's equal to, but 3 is not greater than 3. So we can't include 3, so we'll circle it. But we can include everything, even 3.01, even just on the other side. But we represent 3 by circling it, and then we shade this way because anything above 3. So have some sort of test point. I'm going to test 2. If you're not really sure which way to solve, test 2. Well, let's go back to the original. 7 times 2 and minus 4 times 2. 14 minus 8 is 6. Is that greater than 9? false. So we know that, oops, I apologize. We know that that is not going to work. So we shade the other direction. On this one, negative 3x plus 1 is greater than 13. Subtract 1, divide by negative 3, but if you notice, this switches. This is something you've got to be careful with. Anytime you are dividing or multiplying using a negative number. I don't care if this number over here is negative. It's all about what you're trying to divide by or whatever you're trying to multiply by. If that is negative, then the sign actually switches. And so we're going to use negative 2 as a test point. Negative 3 times negative 2 is positive 6, plus 1 is 7. 7 is great. Going back to the original, 7 is greater than 13. This actually doesn't work. Like, I have to go the other way. If I would plug in negative 6, negative 6, negative 3 is 18, plus 1 is 19. That's greater. We know we have to shade that side. With a fraction, this is just multiplying to get rid of that rather than dividing like we have been doing. So we subtract 2, then we actually multiply by 4, and we have this greater than or equal to, which means this right here is actually a closed circle because we can use 4. 4 over 4 plus 2 is 3. 3 is equal to, that's what that equal part is. We got less than and equal to. 3 is equal to 3, so it works. And then we use our test point. We plug in 2. 2 over 4 is 1/2, so I put 0.5. 2.5 is less than 3, true statement. So I know that when x is 2, I'm okay. So that's concept number 11. Concept 12, and or. And we kind of talked about these already. If you see something and something, then your numbers has to be true for both equations. There's 2 ways of writing it. X is greater than 2 and x is less than or equal to 5. Or I can go x is greater than 2, kind of backwards, and x is less than or equal to 5. So basically x is in between these two. And so we'd have an open circle for 2, a closed circle for 5 because it's equal to, and we'd actually shade in between. Everything in between is my and. Or is usually, well, you can see opposite directions, but it only has to be true for at least one equation. So if x is less than 2, all of these work for less than 2. Or x is greater than or equal to 5. Well, all of these work for that. Now, 1 is not greater than or equal to 5, but because we have or here, it's okay because it only has to work for one of these. With and, it has to work for both, and is usually, not always, but usually 2 dots with a shading in the middle, and or only has to work for one, which is usually, not always, but usually 2 dots with arrows going opposite directions. So I'm just going to end this first video just to make it a little bit easier to upload. We're about halfway through these concepts, and so make sure you're back for video number 2.